Hey guys, today I'm going to teach you how to classify rational and irrational numbers. So there's two types of numbers, rational and irrational, and today we're going to just look at what they mean and what they are. So by the end of the lesson, you'll be able to classify them using your knowledge of decimals and square roots. So everything we know about terminating and repeating decimals, and then perfect squares and non-perfect squares will be really important to today's lesson. So go ahead, get out your binder, turn to the math section, and get ready to take some notes. So let's go ahead and get started with the definition. The first one is rational numbers. So rational numbers are numbers that can be written as fractions or decimals. So if you notice, the word rational has the word ratio in it. So ratio means fraction. So any fractions or decimals are called rational numbers. So most numbers that you know are rational. For example, 1/2 is a rational number, which also means that 0.5 is a rational number. So 0.5 is an example of a terminating decimal, which means that it ends. So rational numbers include terminating, but they also include repeating decimals. Remember, 0.5 is terminating because it comes to an end. Everything after the 5 is just zeros. But another rational number could be 1/3, which as a decimal is 0.3. And the 0.3 repeats. So it has the little hat on top of it. That means it's a repeating decimal, but it is also rational. Any fraction you can have is a rational number. Rational numbers are fractions. So this also means that whole numbers are fractions. Remember, every regular number, like the number 5, has an invisible 1 underneath of it. So every whole number is also a fraction, so it's also rational. So any whole number is rational. So this leads me to my next point. The square roots of perfect squares are also rational numbers. So for example, the square root of 25, 25 being a perfect square, comes out to be 5 or -5. Both of those are rational numbers. They fit into this category because 5 is a rational number. It can be written as a fraction. So anything that can be written as a fraction, any whole number, and any terminating or repeating decimal are called rational numbers. So what would irrational numbers be? Irrational means something that doesn't make sense. If you're acting irrationally, you're behaving in a way that doesn't make sense. So irrational numbers cannot be written in fraction form. So what numbers cannot be written as fraction forms? Let's look at it. Any non-terminating and non-repeating decimals are irrational numbers. I can't write those as fractions. So the most famous example of that is pi. Pi is the decimal equivalent of 3.14. So it's about 3.14, but there's never going to be an exact decimal answer for pi because pi talks about circles, and circles go on forever. So pi never has an end, it never has a pattern, it doesn't repeat. So pi is the most famous irrational number. So you can't write pi as a fraction. So pi is irrational. The other thing that we might see is the square roots of non-perfect squares. So for example, the square root of 5, I can type in my calculator and I will get a decimal answer. But that number doesn't make sense because remember, square root means what number times itself gives you the number inside of it. There's nothing times itself that gives you 5. So the decimal answer to the square root of 5 is an irrational number. It doesn't make sense. So go ahead and pause the video now and think of another example of an irrational number, and then press play when you're ready to check. Okay, so by now you just should have thought of any square root of a non-perfect square. So the square root of 3, the square root of 27. You can look back on your chart for non-perfect squares, and just any square root of those numbers is irrational. It doesn't make sense. If you thought of a fraction, you were thinking of a rational number. Any fraction is rational. Any non-terminating and non-repeating decimal is irrational. So pi is irrational, and the square roots of non-perfect squares are irrational. So let's take a look at some more examples. If you want to pause the video now and try all these by yourself and then press play to check, that might be a good idea since you have all the definitions you need. You can also go along with me for a couple and then pause and then try them, then press play. So it's up to you, whatever pace you want to go at. But I'll go ahead and get started by looking at the value of -12. So it says fill out the table and determine if each value is rational or irrational, and we'll have to have an explanation. So the value of -12. So it doesn't matter if the number is negative or positive. I know I can write -12 as a fraction. It's the same thing as over 1. I also know that it is an integer, and all integers are rational numbers. So I know this is rational because it can be written as a fraction. Let's look at the next example. This symbol is the pi symbol. Remember, we can get close to 3.14, but it goes on forever. It doesn't stop at that 4. It goes 3.14159 and so on. So this is an example of an irrational number because it is a non-repeating, non-terminating decimal. So when you think irrational numbers, you should think pi. You should think that it's irrational because it's non-repeating and non-terminating. Let's look at the next value. It says 0.6. There's no dot, dot, dot afterwards. There's no line on top. This decimal comes to an end. That means it's a terminating decimal, so it is rational. Let's go ahead and look at the next one. Hopefully you start to get a hang of this. You might want to try the next ones by yourself and then come back to check. 7/8 is a fraction. Any number that is a ratio or a fraction is a rational number. I can write it as a fraction. Let's look at our next example. It says 0.12345 dot, dot, dot. So that means it's going to keep going. Pay attention to this. This is an irrational number. There is no repeating pattern. So it doesn't go 0.121212. It doesn't repeat 123 123. It doesn't go 123 4 5 6 123 4 5 6. There's no pattern. So even though it looks like there might be because it looks like it's increasing, it means that dot, dot, dot means it's never going to end and there is no repeating pattern. So this one would be irrational. So the next value, 0.33333, on the other hand, does have a repeating decimal. So if it repeats or it ends, it is rational. So again, just to make sure we're on the same page, the difference between this one and this one is that this decimal does not come to an end. That's what the dot, dot, dot means. So it does not terminate and it does not repeat. So every number is unique. It doesn't have a repeating pattern, but 0.3 repeating has a pattern because it's 0.33333. So it's repeating, which means it is rational. Let's look at the next one. It says, what's the square root of 20? So what number times itself gives you 20? So I know 5 times 4 is 20. I know 10 times 2 is 20, but there's no doubles. There's no number times itself that gives you the number 20. So if I type it in my calculator, I'll even be able to check that way. I can see that the square root of 20 is an irrational number. Let's look at the next one. It says negative 1.75. So it's like owing me $1.75. That is a rational number. That can make sense to me. The decimal comes to an end, which means there's nothing after the 5 or zeros after the 5. So this is a rational number because it is a terminating decimal. And let's look at the last one. So you have a negative on the outside of the square root of 121. So I'll try to simplify if we can. Let's take the square root of 121. So we're thinking of a number times itself that gives you 121. So 10 times 10 is 100. 11 times 11 is 121. So the square root of 121 is 11. And there's a negative on the outside or an opposite on the outside. That just means that the answer would be negative 11. It doesn't matter if the answer is negative or positive. That doesn't determine whether it's rational or irrational. It's a perfect square, so it is rational. So go ahead and make sure that you have all these examples written down. Go ahead and take a second to make sure you have all of these examples written down and you understand why each of these is rational or irrational. To me, the rule is very simple. If it's a fraction, it's rational. If it's a perfect square, it's rational. And then any other number that you cannot write as a fraction or a decimal that doesn't ever come to an end, it doesn't ever repeat, any number like pi, those are irrational. So the next 4 questions are applications of what we just learned. I want you to go ahead and pause the video and I want you to try each one of these by yourself first and then press play to check. So let's start with number 1. By now you should have tried all these by yourselves and now you should have pressed play to check. It says Joseph wants to find the side length of a square that has an area of 150 feet. So let's go ahead and draw that out. There's a square with an area of 150 square feet. So that means that he's already done the length times the width. Remember, the length times the width gives you the area. And since it's a square, the length and the width are the same. So should his answer be rational or irrational? So to find the area, we do length times width. So that would be like squaring a number, which is why we see this little squared sign. So to undo that, you don't divide by 4. Remember, a lot of you guys were thinking divide by 4. It's not divide by 4. It would be take the square root of 150. So to find the length of one side, you take the square root. And since 150 is not a perfect square, it will be irrational. Let's go ahead and read the next question. Number 2 says, which value or values from the following list of numbers is not rational? Explain. So we're just going to go each one and just see, is it a fraction? If it's a fraction, it's rational. Does it have a decimal that terminates or repeats? If it does, it's rational. Is it a perfect square? It's rational. So let's just go down the line. So this first number here, 8.224, it ends at the 4. So I know that this is a rational number because it terminates. 5/9 is a fraction That means ratio. It means rational. Let's look at the next one. It says square root of 25. I know that 5 times 5 is 25, so the square root of 25 is 5 or negative 5. Either way, perfect square means rational. 0.321 with a repeating over the 321 means that it goes 0.321, 321, 321. So it does repeat. It repeats the 321. So that is rational. And then the last one, the square root of 30 is a non-perfect square. There's nothing times itself that gives you 30. So our answer to this one would be a decimal that doesn't ever repeat and doesn't ever end. So it's a number that doesn't make sense. So the square root of 30 is an irrational number. Let's look at number 3. It says Brad converted 5/11 to a decimal and his result was a repeating decimal. Does this mean the value is rational or irrational? So 5/11 starting out is a fraction. So obviously any fraction is going to be a rational number. So that's the first way of knowing. If you can write it as a fraction, it's definitely rational. The second reason we know is because a rational number could be a decimal with a repeating pattern. So it started as a fraction, which means it can be written as a ratio. And it also means, since we have a repeating decimal, that it is a rational number, just by definition. So make sure that where it says explain your answer, that you're taking the time to write out in sentences why the answer is correct. And then number 4, just a quick check, state whether the given values are rational or irrational. So given means that they give it to you, so they're giving you this, and you are just going to decide, is it rational or irrational? All of them look pretty similar, but there's differences with each one. A, ends. It doesn't have anything after that 7, which means there's nothing after the 7. So on A, this one would be rational. B, however, has a dot, 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 which means that it's going to keep on going forever. And there is no pattern. There is no repeating pattern. So since nothing repeats, 4, 5, 6, 7 is going to go on forever without repeating. So that means it is irrational. The next one says 3.467 with a little repeating sign on the 7. So this is going to go 3.4, 5, 6, 7, 7, 7, 7, 7, and so on. Now that I've got the dot, 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 and I have a repeating pattern here, that means it's going to go on, but it's going to be repeating that 7. That means that it is rational. So anytime, remember just looking at the definition, a number ends or repeats. So this one ends, this one repeats. Anytime you see a number that ends or repeats, that means that it is rational. So I'll let you try 5 and 6 by yourself, and this will be the first thing we go over together, where it says summarize the day's lesson. You can write down anything helpful that you might need to remember moving forward. All right, guys, that's it. If you made it to the end of this video, please put, if you could have any superpower, what would it be and why, in the comments. Today we went over rational versus irrational numbers. Today was mostly just definitions and then following rules. So by the end of this lesson, now you should be able to classify rational and irrational numbers using your knowledge of decimals and square roots. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!